I've got a session going here. Just okay, we are live on the internet. Random org. So checking password for access. So random.org is a pretty cool site. I talked about it last term when we did probability. They have some more information about here about what it means to be random, how they try to improve randomness in their procedures, their algorithms for generating randomness. And they have some really good stuff here if you want to read around it. Starting with their what's the fuss about true randomness. It is a big deal. It's still a problem people are trying to get better at all the time. Because it can be, the more random it can be, the more superior our data will be, the more we can try to understand other problems, the more we can simulate things better, stuff like that. Yeah. So yeah, so there's lots of weird stuff going around us all the time. We can put up certain probes and try to collect that stuff. And so there's randomness in terms of noise, there's randomness in terms of light, there's randomness in terms of other things that are flying around. And we can collect some of that to use. Which is pretty high. So they try to incorporate natural randomness into the things they do. There are some, like if you ever try to generate a random password, there are some sites that, to improve on the randomness, they'll have you do things like wiggle your mouse around the screen, as crazy as you can get. And they'll use that crazy scattered mouse movement to help make randomness. To help you come up with passwords. And so there's a lot of different things people try and get better and better all the time. It would be perfect. Perfect. So it's still kind of an open problem all the time, which is pretty. And then there's all the other people who try to find patterns in that randomness to try to debug. That is really good. I think I mentioned to you guys before, Microsoft Word had a problem with their random number generator or Excel a few years back. Somebody found that it wasn't as random as they said it was. They had to do some serious work to put out a patch to try and fix it. So that's kind of interesting. All right, so what do we got? Couple things. I just in class handed out this data sheet right here. So I got some more M&M data from me, my kids, and some other places. And they vary a little bit, but they're pretty similar to the data we have. I mean, totals down there and percentages. And this is the data that we're going to use, and I'll help get started on a couple of them, the dot plots for the course. Yellow did come up on top here. Keep in mind that this is a relatively small sample set, and so it could be just like blue could just happen with our small number of M&Ms. You know, given the amount of M&Ms out in the world today, although we have a lot of smaller subsets, that helps a little bit to balance that. But yeah, who had the highest number? Orange had the peak at 15, right? So one thing I can do in the spreadsheet is I can have it try to help answer some other questions. Like I could ask the question equals, what is the maximum number in each column? So that's, and then I just highlight the data above, those are my parentheses and enter. And remember, when we have a formula that's similar across rows and columns, I can just copy it across with that magic button. And so I can see that what I thought was the biggest number, that 15 really is. 15 is the highest number on the code. So somebody had 15 orange %. So half their sample was orange. Whoa. Kind of all. What was the smallest number that came? So I can do a minimum. All kinds of questions. 1 was the minimum. Then, oh, no, 0. There was somebody that had no red. Blue is the highest? Okay, oh, and you were saying blue is an easy color, easier color to create, cheaper color to create than
Lowest is red.
red. Okay, which falls under blue image. So our number is going to be close to M&M's, and maybe, maybe not. It's a pretty small sample set. We would have thousands and thousands to try and predict what it should be. But we have started. Yeah, that would be fun, right? Yeah, we just have tons of learners that are walking by. And, so we're going to play with some other data today and play around with some charts and graphs. I'm going to give you some data. We're going to play around with workbook activities. Oh, the course website, I did update that. We got to that last night. And we are going to go through chapter 10. And this was interesting. Somehow Danielle ended up as one of the teachers in the course. I don't know what happened there. So be careful. That gives you special privileges. Don't abuse them. With great power and great responsibility. So I'll get that fixed. I'll have you put it as a regular. I don't know if that's going to cause any problems for you being in the site. Like me as a teacher, it doesn't record stuff I do. That's in BMCC Online. We go to my MATLAB to do work, so I doubt it will matter. I can't imagine. You never know. Crazy shit happens. Yeah, so that surprised me the other day. I was like, oh, that's interesting. So let's see, some things in here. The random card thing I left behind from last term. Good article on math education. If you haven't gotten around to reading that, especially if you're in Math 333, this would be a good article to release an article monthly about good things and bad things about math education. So some stuff. Graph paper we'll use later. Online manipulatives we're going to use. Putting all my recordings in the same place we were before. Oops. Decimals off there, and then math best. Here, and I posted the activities we're going to use so far. $2,000. So activities, we start with activity 1, we're going to start on activity 2. Okay, and then the M&M data is a Google spreadsheet I have linked here. That's the same one I just printed for you. That's also displayed right here. So you can go ahead and do that if you wish. And then, let's see. I went over how to make a histogram in Excel the other day. It was rather complicated. The instructions for doing that are located here. And we'll do that again today. So, it's there. So I dumped a whole bunch of data from the student records campus. I went through it in this spreadsheet here. Excuse me. And what I did, I had the computer calculate the age of a bunch of students. So I have a sample of 118 students and their ages. And I kind of shuffle them so they're random. There's no other information. There's all different kinds of data that we can collect. There's quantitative data, which is some kind of number. There's qualitative data, which is some kind of name or something. And there's some things that are kind of a mix of the two. For example, here's the term, 20154. You guys have student numbers, right? That's a number. Would it make sense to find the average value of all the student numbers? Or to maybe find the difference between Greg's and Danielle's student number? Maybe your student number is 1,000 more than his. That's the calculation. Can you think of any meaning a student number has? Well, like someone's social security number. Does it make sense to add up your social security numbers? It's just a number used as a name. So sometimes when we have data that looks like numbers, it's really not. It's a name using digits. So here, yeah, so my recollection is summer is 1, fall is a 2, spring is a 3, summer's 1, fall is 2, winter is 3, and spring is 1. So the 2154 must mean this was the spring of 2015. Add time. Time is a little different on computers. Time is often measured in the number of seconds that have elapsed since some fixed time. It could mean something else too. My guess is this is some number of seconds since some dates that we have time. It correlates to 10:38 a.m. It could be milliseconds. I'm not really sure. It depends on the system. So could this be a number that's useful as a number, something we can add, subtract, multiply, divide? Maybe. Is this term number something we would add, subtract, multiply, divide? No, that's just the name of something. It's the name of a term using digits. So just because we have data that looks numerical doesn't mean we can apply any statistics to it. Yes?
Is the grade just, is it a math class or just?
That's a grade for some class. So I'm just going to write down some more information about the different kinds of data that we can collect. Just so that we're aware of, sometimes there are things that look like numbers, but they're really not. So types of data. So we can break data down in a few different ways. We have qualitative data. And so qualitative means it describes some quality. Could be a name. Like I've done some construction work, and often a popular construction material is a 2x4. Well, if you ever measure a 2x4, it isn't 2 inches by 4 inches. It's been planed down to be smaller than that. And so it's a 2x4 in name only, not in any kind of measurement. So sometimes people refer to it as a nominal 2x4 or a nominal 4x4. It's not actually 4 inches by 4 inches. It might have been cut that way originally, but they cleaned it up and it's smaller. So sometimes we use numbers, but that number is really a name. Sometimes we don't even use numbers, it's just a name. Like, for example, in the room right now, we have 2 males and 2 females. That is data, but it's not numerical. But it is important data to collect. So that would be some kind of qualitative data. So example, gender, color, think of anything else, data that might be worth collecting that's
Hi.
qualitative. Height would be a measurement, so that would be numerical. That would be qualitative. Type of clothing, yeah, a shirt or a t-shirt or a button-up or a sweater maybe. Material the cloth is made out of, is it made out of cotton or polyester or some other weird space age material or recycled pop bottles. So can we do things with can we do statistics with qualitative data? Sure we can. Right? We could take a look at the proportion of males versus females. How many people like red better than blue? Things like that. So we can still work with those numbers. We can still do some statistics, but we can't can we average the colors? Like what's red plus green divided by 2? I mean, you can put numerical values to color, but that's a whole another story. Could I do something like male plus female over 2? I mean, there's some statistics we can do, some we can't. We talked about mean and median before. Those are for numbers. Mode could be used for qualitative data. What occurs more often, male or female, red or blue, things like that. Polyester or cotton, or whatever else. So some statistics work all the time, some only work some of the time. Majority of the kind of data we're concerned about is quantitative. Quantitative data has something to do with number based on our previous experience in math together. We have 2 kinds of numbers mainly. We have numbers that are discrete, or sets that are discrete, versus continuous. So discrete means countable. And although continuous can be countable, usually it's not. So countable like 1, 2, 3, like the whole numbers. Continuous would be like drawing a line to get from this point A to this point B. I do not lift my pen. So that's a continuous line. Countable is a bunch of points, perhaps. Often, if we measure something, it's some kind of continuous data. If we have a really accurate scale when we measure weights, there's probably 50 many possible weights out there. We usually say that's a continuous data. Whether it's discrete or continuous, there's a further breakdown in data. So I mentioned earlier, we could have a quantity, like, for example, your student number. So my student number is 1185450, I think. Somebody else's student number might be 1, 2, 3, 5, 6, 6. Those are just a different way to refer to Gary Parker here or some other person here. But it doesn't make sense to add, subtract, multiply, divide, or average those numbers. Okay. So this type of data right here is called number. It's a quantity, but in name only. I could just as easily call this Gary Parker. Human beings attempt to try and make some unique identifier. Like, are there other Gary Parkers out there? Absolutely. My middle initial is G. Are there other Gary G Parkers out there? Yep. I got one of them who thinks he owns my email address and always getting his mail. Turns out he's a statistics teacher in New York. I started teaching in July. He's a G also, yeah.
So, social security number specific.
Same thing, it's a name, so there's another name for Kelly, or for Gary. It's a unique way to identify somebody using digits, but it's really just a digit name for you. So that's called a num. It doesn't make sense to do a lot of math on it because it's really not about math. Zip code is another example. There's my mom's zip code. If that were a number, I wouldn't write the leading 0. If I were to type that into Excel like that, Excel would ditch that leading 0. Get rid of it. Then there's a problem, because now it's not a zip code, right? Because it doesn't have enough digits. So that's a number, but it's really a name for a place using digits. Other types of quantitative data would be things like if I list you guys from alphabetical order, let's say by first name, then Danielle gets to be first. And then Gary gets to be second. And then Greg gets to be third. And then Kelly gets to be fourth. So Danielle is first, Kelly is fourth. If I take 4 minus 1, I get 3. At the moment, Kelly and Danielle are 3 apart. Is that an important subtraction? No, because later I'm going to sort you guys by last name. 1 apart or 2 apart. So it's a little more powerful than a nominal because it's not just a name. I put you guys in a certain order. There was a reason for the order. Nominal data, there's really not any order to it. It's just a number assigned to you. So this is called ordinal data. Subtraction doesn't make sense. Doesn't make sense to add them. Doesn't make sense to average them. It might make sense to find the middle one. I don't know why. So we're using numbers. They're just to put things in some kind of order. Maybe there's a reason for the order. You were the first person to get in the room. Alphabetical by first name, alphabetical by last name, maybe by age. Yeah. Yes, just somebody's seat number might be in the place you want. Yeah, maybe good. All right, next stage of quantitative data is what's called an interval number. Example of an interval number would be like temperature. Let's see, Google, what is the temperature right now? Got 63, 63, 64. Okay, earlier this morning I was biking to school. It was around 41-ish. My fingers were quite cold biking to school. I'm looking forward to going home because my fingers won't be cold. That's some nice weather. So 41 degrees Fahrenheit versus 64 degrees Fahrenheit now. What's that, a jump of 23 degrees Fahrenheit? Right, if I take 64 minus 41, that is a reasonable thing to do, right? To say, hey, the temperature jumped 23 degrees. I'm glad, because I didn't wear a jacket. It was chilly this morning. I hope it wasn't going to be chilly coming home. Notice, temperature does have an order, right? Would you all agree 41 is less than 64? It's also a name for that temperature. So you could say it's nominal data, you could say it's ordinal data, but since subtraction now makes sense, we usually say it's an interval that's important. Next question is, does 0 make sense? 0 degrees Fahrenheit, is that important? What's important about 0 degrees Fahrenheit? Anything special happen in the universe? Not really. How about 0 degrees Celsius? Anything important about that one? What's important about that? Only at sea level on the right barometric pressure. So if you go way above sea level, way below, it's 0 degrees Celsius is now
converting
meaningless.
from Celsius to Fahrenheit. You need to know what it is.
Yeah, so really, does 0 mean anything in temperature? No. It turns out there is an absolute 0 out there. And if we take that into consideration, that would bump up temperature to a new level. But at this point in time, if we're just talking about Fahrenheit and Celsius and our average daily interactions with temperature, its interval 0 is pretty useless. If 0 was useful, it would jump up into the category of quantitative data called a ratio. So this is sort of related to like our development of the number system. First we learned to count, then we learned about negative numbers, then we learned about fractions, then we learned about real numbers and crazy square roots. Similar to this, not exactly the same. So ratio 0 matters. Any of these numbers could have been discrete or continuous. Although usually with nominal and ordinal, it's, I guess nominal and ordinal is definitely discrete. Okay, so interval and ratio could either be discrete or continuous, depending on the kinds of things we're measuring. And quantitative data generally relates to some kind of measurement. Age, height, temperature, it's a measurement. Okay. So let's do something with some data. So I collected some data. Let's see. I have 2 sets of data. Ooh, I just thought of another data set. Yes. What I wanted to show you is a survey I wrote and got some data back. The survey is kind of visible here. This is the column heading. So I asked my statistics students some questions. So one of the questions was, what is your height in inches? Pretty straightforward, I think. And mostly I got reasonable answers. 62, 61, 60, and 64.8 response. 70.05. Accidental submission. Another question I asked was, how much money do you have on you? Okay, how do I answer that question? Don't have my wallet on me. Keys, phone. Oh, 75 cents. What should I type in? 75? 0.75? Yeah, so will everybody know to do that? So it's important to word questions well, and it's hard to do sometimes. You have what's in your head at the moment, and you write down the words you think go with what you're looking for. Will people find a way to misinterpret you?
400.
Oh, yeah. Right.
Most likely it says 400.
Oh, yeah, somebody wrote 400. Okay. Maybe they had $400 on it. Yeah, this person wrote $50. This person wrote $32. 0.35, 35 cents. They were pretty clear about that. $3.50. Sometimes when we collect data, though, we have to scrub the data after, clean it up so we can use it. Because right now, if I tried to average these numbers, the computer would freak out about the dollar sign and the word dollars. Other problem I have, since it's not clear about how I want people to state their money, in dollars, cents, euros, whatever, what's the new thing, Bitcoin, I don't really know what these numbers mean. I could assume they all mean dollars, but I don't know that. Right, so here I have some data that might not be usable. I asked people for the last 4 digits of their student number separated by commas. And people had a hard time with that. Pretty common. One reason I asked for the comma separation is that I could tell Excel to split this data up using the commas to put it in new cells so I can analyze it. Like we did the other day, I asked people to give me some random digits. Slight problem here, this person didn't know what digit meant. 106, 92, those are numerals. So that wasn't clear. What is your gender, male or female? Now, that one, I gave them a checkbox. They had to check off male or check off female. Because otherwise I'll get problems with people misspelling male, female, or maybe throwing something else I wasn't expecting besides male, female. They could put other. Yeah. This one, do you exercise regularly? Yeah, what's exercise? Like I got it up and down out of this chair a few times. That's pretty regular. Okay, so there's problems with that question. What is your favorite color? Green, purple, earth green, right? Some people are specific, mint green. Teal. Black's not a color. Technically, yes. Okay. Is that white? Yeah. Oh yeah, white. No. White is all colors. Black is absence. I thought it was the other way. Is it? I don't know. Floral. Ooh, that was a good one. And there's some standard stuff here. So I could timber green. This person's probably a soccer fan. Turquoise. I cannot spell turquoise on a good day, so it's possible I could have 3 different spellings of turquoise in there. So data collection is kind of troubling. What kinds of weird things now? Then I asked for some things that were pretty straightforward, sort of. Like what is your pulse rate in beats per minute right now? So let's add our data to that and play around with this data a little bit. And then we'll work on the projects. So everyone know how to get your pulse rate? So usually what you do is you count for like 15 seconds and then multiply by 4 as a clock on this. You can get it on your list. The Everest key. So feel around, see if you can find a pulse rate. The clock behind you can find that. Okay, so mine came in at 112, if I counted right. I have copies. else get pulse rate?
68.
68. So that's like pulse rate. So I got a whole bunch of pulse rates right here now. I have possibly 69, but some people left it blank. So one thing that might be good to do is to sort the data. So I like data. I like to use sort range because then I get options. So I can say my data has a header row. I can sort my data by pulse rate. A to Z, smallest to largest.
So that's just sort of the number, you sort everything.
Yeah, so if there was other data, it would sort everything, which is really the way you want to do it in general, so you don't separate people from the pulse rates. Yeah, so the option here to sort by range, not a good idea. You should almost never do that. You always want to sort the whole sheet. So I got this data that goes from 54 beats per minute up to the new high I just put in there 112.
You're at 112 right now?
Me. Yeah, I had some heart problems last year, and since then my average heart beat's been 20 beats higher than it used to be. So, Kelly, you got one?
Is it for 30 seconds?
For a full minute.
White is all colors, black
Okay. Okay, we'll put in 60 now. So Greg says white is all colors, black is absence of color. With lights. And light,
is. In thinking of colors as far as
when you're building colors, it's pretty much the other way around because of reflection. And that always I find very confusing. So that sorts. So Kelly's in there. That's not a lot of numbers, but it's enough that I really can't just look at the list and get a feel for what's going on there. So usually we want to make some kind of graphical display of the data. So I'm going to just reload this so we can see the numbers. I'm just going to show you some other kinds of charts we can make. So let's say we're going to do 10 at a time. Right, you guys over here in the stem leaf graph. Your dot plots, plots. Viewable. That. guys see all those numbers? So here's our goal. What a stem and leaf graph is to categorize by usually tens or hundreds, something like that. So we're going to go by tens. So I have my 50s and my 60s and my 70s and my 80s and so on. And when I make the actual chart, page, and I get my stem on this side, and my leaves on this side. And so for the stem, I write a 5 for the 50s. And then the leaves are the ones digits. And so the ones digits would be a 54, 54, and 9. So what I would write in my diagram here is that I have 4 and a 4 and 9, like that. And then I go and look at the 60s, and I do the same thing. So for the 60s, I have a lot of 60s. So this is going to take more time. So I write down all my zeros, then a 1, then a 2. So there's 5 zeros, a 1, a 2, and some 3. So what that would look like is for my 60s, I have 1, 2, 3, 4, 5 zeros. You try and line them up vertically. And then there's a 1, 2, 3 threes. And I'm kind of running out of room to do my chart. Touch. You get the point of the stem and leaf here? So I'm going to try and create one looking at the data. So I'm going to bring the data back up previously. No, I left off with the 4 there. So we still have 2 to do. Just making sure that stem and leaf graph. Yes. So that would be a 10 and then an 11, right? because we're separating the ones digit as the leaf. So there'd be no tens, which would be like 101, 102, 103. And we get up to 112. Does that make sense? I'll draw it. Yeah, you do. Okay. So that's what I'll draw that. Yeah. Skip. There's no 100, something. There's a 1 something. That's so get this benefit. So line up there. So let's see this.
The answer to my numbers don't let me.
I just can't think of the right spot. There it is. Enough. That was there. 3 3s, then I got 4 3 5s, 2 6s, 3 8s, 7s, over 4 70s, a whole bunch of 72s. And I'm trying to get them to line up column-wise. So with kids, I would use graph 3. That's 3, 5, 5, 7, 8, 5, 6, 6, 7, 8, 9, 9. And my 8 is a whole bunch of 8s, 8 of them. Or 3, 5, 7. Hello.
Hi.
90. We're doing a stem and leaf graph.
Okay.
92, 93, and 98. 99, next comes 100. If there was 100, it would look like that. 101, 102, if they existed. There were none from the 10. There were none in the early hundreds. The next number was 112. So it looks like that. Because there were no 101s or 102s or 109s, for example. So that is what the stem and leaf graph would look like for this particular data set. Now, if the data set was any bigger than this, it would be very annoying to build this by hand. So for small data sets, working with kids, this is a great tool to have graphical display of data. Gets the whole idea. It gets a little tricky over here, granted, with the place value part. But after a couple of tries, they will get it. So a stem and leaf is a kind of histogram. I talked about histograms the other day. We're doing histogram. Yeah. Yes, to put 12 over on this side, right? Because the leaf is usually just a single digit. So there's some data that this wouldn't work with. What's that?
You actually rotate it.
Yeah. So we're going to do that in just a minute. So we're going to do this a slightly different way. So Debbie,
Yes.
catch you up on a couple of things. I was playing around with data that I took in another class where we collected heart rates, pulse rates.
Okay.
And so here's a sample of the pulse rates that we collected. And we were deciding that that's a fair amount of data there. There's, 66 numbers, and it's hard to look at that and glean information from it. So we try to make a graph of it. So I'm just going to make a couple of other graphs of this data. And so I can share this data with you so you have access to it. Can you remind me what your email address is again?
The BMCC one or
Well,
the high?
how do I usually invite you?
Invite me. Okay, it's Debbie.Smith
That's right.
at hermistonsd.org.
All right, so I just sent that to you. You get an email saying I invited you to edit this data. So then you'll have it in front of you instead of disappearing from the screen. So we're gonna
Perfect.
make this data just a little bit. So you've got your stem and leaf graph in front of you. Another kind of graph that we could make would be a dot plot. And let's use just a subset of this data. Let's say we're going to use the first four. So up to that second 76. So I'm going to steal that data into here. So next graph we'll make is a dot plot. After that we'll make a histogram, and then we'll go to the computer lab and get started with the next project. Oh, and also, Debbie, I have some more M&M data, and I put a link to it in the announcements on our BMCC Online site.
Okay. Is that working now?
It is, yeah. So I have homework in there and some announcements and links to things that will be useful. I also put a few practice tests in there.
Okay.
So for my dot plot here, this one's going to start at 60 and then go up from there. So it's 61, 62, 63, 65, 6, 7, 8, 9, 7. 1, 2, 3, 4, 5. I'm going to stop at 76 because that's all the data I decided to look at here. And a dot plot, the book shows putting X's. You can use dots, whatever is convenient. I'm going to use dots. I'm going to dot plot. Oh shit, I forgot my 50s. Right? Over. It's 50s in. So there's my 54. So I just put a dot above or an X, and it's kind of like making the stem and leaf. We just don't write the stem and the leaf. We have the numbers, some of the numbers at least enough to figure out what's going on some horizontal scale. The size of the 50 over there. So there's 1, 2 54s. There's 1 59. And in the earlier project 1 showed them using X's to build a dot plot. 60s, how many do we have? 1, 2, 3, 4, 5. So there's a single 61, a single 62, 3 63s. So 64. dots line up vertically and horizontally. 66, 68, 70, and a whole bunch. Away, there, 72, a whole bunch. There's 6 of them. Fours, 75, so at least for this segment of the data, this is what the dot plot would look like. So a dot plot gives us a view of the distribution of data, just like the stem and leaf does. It's just a different way of putting it together. And again, for messy people, doing this on graph paper is enormously helpful. And I know very few need to. Or some. So that would be a dot plot. Next, we're going to build a histogram. To build a histogram, we need a frequency table. So let's talk about frequency tables. For a frequency table, you got to decide how you're going to group your data. So you need some kind of grouping system. The groups are also known as classes. Sometimes you hear them called that. Sometimes they'll be called bins. Sometimes they'll be called buckets. There's other names for them too. It depends on what software or what book you're looking at. And then we want to count how many are in each group. That count is known as a frequency. So the word count and frequency are used synonymously. So for my data here, one possible grouping system would be to say, I want anything from 50 to 59 beats per minute in one group, and then I would want 60 to 69 in the next, 70 to 79, 89, 90 to 99, 100 to 109. Get in there for this data. To 119. When you make your bins, you're going to have some starting point. So my starting point here is 50. And then you have to have a bin width. And the bin width should be consistent. So you want to have a constant bin width. Otherwise, it's not a histogram. It's some other chart. So here I decided to start at 50, and what is my bin width here?
10.
It is 10, careful. So the bin width can be deceiving. The best way to calculate the bin width is to say subtract 2 beginning numbers in the bin. or subtract two ending numbers in the bin. So if I take 60 minus 50, I get 10. If I take 79 minus 69, I get 10. That is the width. Well, I can put any number from 50 to 59 in there. And if you think about the ones digit being significant there, that's 10 different digits. 0 through 9. Okay. But subtracting the endpoints of the bin is not going to give you the bin width. Okay, so you got to be careful about that. And it gets trickier if there's decimals involved. Like what if people that have fractional heart rates, like 59.1 and 60.9? Where do they go? So often, when you're constructing your bins, you got to consider, should you put any decimals in the bin with description? Am I really starting at 50 or am I starting at 50.1? Am I going up to 59 or am I going up to 59.9?
When you plug it in an Excel and spreadsheet.
We'll get to that part in a minute, yeah. So
Where do we start?
what the spreadsheets do to calculate a frequency table is they only care about the ending number for any particular bin. That's all they want to know. When do I stop looking for this category? Once they know that, they sort everything else out. So as far as computers and frequency tables, we have human mutable bins, which is what I'm creating here. And then there's bins for a spreadsheet program where we only give them the maximum number, 59, 69, 79, 80. So first I'm going to do it by hand, then I'll do it. All right, so the next thing that needs to go on my frequency table is the actual frequency. So frequency and count are pretty synonymous. So then I say, well, how many things were in the 50s? Well, you guys have that stem and leaf graph in front of you, right? How many 50s were there? There were 3. Okay. So I would just put 3 there. 60s, according to that stem and leaf graph.
20.
There were 20? Wow. Okay. Anyone else confirm it? I got somewhere between 19 and 20. You get 20? Okay, we better count it in the all right, and then I think there were 3 more 70s, is that correct?
Yep.
So for the 60s, we found that there are 23 70s. How many were in the 80s?
14.
14. 90s?
5.
There were 0 in the low hundreds and 1 in the 100 teens. Now, a frequency table is dependent upon the starting point of the first bin and how wide each bin is. I happened to choose because it was convenient 50s, 60s, 70s, and 80s because it matched the stem and leaf graph, which we had already done, making this a very easy histogram or frequency table to create. It could be I want to group differently. Like maybe I want to start at 54 and group by 5. I would get a totally different table. And then have to recount everything to make that happen. So what's better is, for us, since we are able to use spreadsheets, we're going to do it on a spreadsheet. So with smaller data sets, kids playing around, we can easily do this. This data set's kind of pushing it for size to be fine. Again, this is a frequency table. I can turn a frequency table into a histogram by making the bins the horizontal axis and the frequency the vertical axis. So let's just draw that next. So I've got my 50s, 60s, 70s, 80s, 90s, 100s, 10s, and so on. Then I'm going to scale here by, let's say, 5, 10, 15, 20, 25. Room up there. That's this. It's not tracking this. Just go. And so then I just make a vertical bar. So it's just a bar chart. A histogram is a bar chart based on a frequency table. So we had 350s, which is somewhere around this high. And we had 2060s. We had 2370s. That high. We had, yeah, how many were the 80s? 14?
Yes.
It's about right there. 90s. Right there. We had nothing in the hundreds and white item in the 110s. So this is one possible histogram of a sample of pulse rates. Horizontal axis being the pulse rates. And the vertical axis being the frequency. Right. And there's a ton of different possible histograms to make. What's the best histogram? Well, the best one is the one we decide is the best one. So I'm going to make one in Excel and then I'll make one. Depends on the data, yeah, and you never know until you make one. And it's kind of like when we solve any kind of problem, we really don't know what's going to happen until we do it. So I'm going to take this data and I'm going to copy this into Excel. Is it really much fun? So it doesn't really matter how your data is organized, whether it's vertical, horizontal, or in a block like this. To make this happen in Excel, I need to have some bins. Sometimes bins, what's another word for bin? Bucket, or class, or group. Sometimes categories. And then we have.
Excel recognizes all those words.
No, it does not. And it depends on which part of Excel you're using. Sometimes you use different terminology. So I want a column for my bins, a column for my groups. I think Google Sheets calls them buckets in some places, and then it's got another place. So it's something you gotta get used to. The computer only wants the maximum number in each category. And then I have the human readable words too. So I might decide that, I think I'll start counting at 52, and then I'll go up to 52, 54, 55. So if I do that, then the next one is going to go from 56, right, up to
59.
Yeah. So here I chose a starting point of 52, and I'm jumping by 4. And then I can write all those out. Excel does not, or Google Sheets does not want those human viewable bins. It only wants the maximum allowable number for each bin. So it wants the 55 and 55. Once I've established one pair, it knows the distance between, so I can use that highlight and autofill to go farther. And I just need to go far enough so I can count all of the numbers. So I have a lot more bins. Usually when I'm making a histogram, we want somewhere between like 5 and 20 bins. Less than 5, it looks stupid because it's only 2 columns. More than 20, it's too messy and hard to look at. So usually I aim for somewhere like 9-ish, somewhere in the middle. So this feels like too many for me, but I'm going to go for it. And I posted instructions on how to do this step by step on the website. I'll go to it again. So once you decide on your bins, you got to make a column that shows the maximum values. For my mother, to make sense of it, she's going to want the human viewable bins. And those I just have to type by hand. There's no different those. For frequency, you have to highlight a cell in the frequency column. For every cell, you have a bin plus 1. Because it always wants to double check, did you miss anything? Why didn't I have to do one before? Well, because it's looking for any number below 55 and lower. So that gets everything before. This cell gets anything after. So the spreadsheet is always looking outside of your range, just to make sure you didn't mess anything up. Once I've highlighted those, I type equals and then start typing the word frequency. And the computer says, oh, you want the frequency command. I hit tab to select it. Frequency command says, where's your data? Data happens to be up here. I don't think it's going to mess up with those blank rows, but let's see. And then it says, where are your bins? And I put a comma, and I can move where my bins. I like that. And then I close the parentheses. The natural inclination of a person is then hit enter, but you can't do that. You have to hit Control-Shift-Enter for Excel to calculate correctly. So then I do Control-Shift-Enter. This is in the instructions on the website. And then what it does is it counts how many are in each grouping above the previous number and up to the number that's listed as the max group. So remember, the bins the computer needs for the frequency function to work are the maximum allowable input values for each category. So this category here will be from 60 to 64. And this one will be from 65 to 67. And again, there's no quick way to do those with type of line. If you try to highlight, put it down, stuff happens. They tried to guess how easy it is. Cool thing here, and then usually I would have all these typed out, and so I would highlight this column, let go of the mouse, hold Control, highlight this column, and then I would say make a graph based on those two. Control key allows you to select disjoint things. So I can go Insert, Recommend Charts, and it will probably pick a bar graph for me. So here's just a part of that frequency table, or histograms. I didn't do the whole thing because I didn't finish typing out those. Alternatively, you could just make the table based on the bins there, but then it's hard to decipher which column. And usually I try to make it so my last extra column here is 0. I want them all contained inside. But Excel never checks. Insert. This right here is just a line histogram. Here's a regular histogram. Usually with a histogram, we have the bars connected, and I can tell Excel by right-clicking on those, format, so I just drop the gap width, and then it connects from that. And that's usually what a histogram looks like. Can you see the problem with the 55, 59? You know, my mom's going to look at that and say, what do you mean 55? So people that only had a pulse rate of 55, where the 54s go? Should we not do that? So that's why we do the human readable bins to help it make people make sense of all that. We can put a little note underneath explaining what that number means, but that's kind of convoluted and weird. So if this is something I'm presenting to somebody, I make the bins for Excel, I do the bins, and I type by hand the human readable bins so that I can highlight with control to make my graph. Here's something that's even cooler, check this out. The frequency command is using my data and my bins. What if I change my mind on the bins? Check this out. Suppose instead I want to start at 52 but jump by 5. So that means it would have gone from 52 to 56. Okay. So I'm going to put a 56 there. And instead of a 59, that would be a 61. I want these to be 5 apart. And so I highlight that pattern, put it down, and the frequency program will recount everything and redraw the histogram for me. So I can just play around what was better. Oh, do I like that one better? You know, maybe I want to do it different. Maybe I want to start at 57 and then jump by 6. 3. Sorry, and the first category of 57. And so I can just make a whole bunch of different ones on the fly here. One problem you can run into is if the first time you only had a few bins, and later you want more, you got to redo the whole thing. So it's not a bad idea to do a ton of bins at first, and then you can back off from it this way. Otherwise, you have to redo that frequency command each time, which isn't too bad once you've done it a few times. Now, remember I showed you the other day, Google does histograms a little bit different. Google can do it this way too. Let's go over the pros and cons. So I'm going to go back to my Google data. I could say, hey Google, can you make me a chart out of these numbers by going to Insert, Chart, and Google says, sure. Oh, that's going to be your stuff. Chart types. Usually, if you want Google to make a histogram for you, you want the data to be all in one line. If my data is not all in one line, Google is freaking out. So I'm just going to go recap the data here.
Right.
What's that?
Is it because it's the way that it works?
Yeah, and Google assumes that since each of these is in a different column, it's special. That column is special. So it makes each column a different column. And that is cool in some ways, but not in others. It depends what you're doing. So one nice thing about Google is it does a lot for you. One bad thing about Google is it does a lot of things for you. It goes both ways. So I'm going to throw that extra data we had. What was it? We had 65, we had 112, we had 68. So if I just highlight a list of numbers like this, Google's going to try and is probably going to assume I want a history. So just highlight all those numbers, insert, chart. It says, hey, want a histogram? Then it's saying, oh, there's a ton of numbers. There's similar kinds of numbers. He probably wants to sort them out. Histogram is one way to sort them out. Cool. If I don't like the bin width Google picked for me, I can go to customization and say, please give me a different bucket size. So instead of a bucket size of, what do we have here, 7, I want a bucket size of 6. And it will redo it. So then I say, yeah, that's a nice one. I like that one. Oh, I want to try 5. No, I don't like that one. I like 6 better. So I can kind of do a live preview of the data. What's the downside to this? The downside of this is I don't have the frequency table. All I have is a picture of it. Which is, I just have a picture of it. So if I needed the frequency table for some reason, I have a problem. I'd have to generate it. How would I generate it? The same way I did before. I'd have to come over here and have to say, okay, what are my bins? Do my frequency next to it. And the only difference in doing it here in Google is instead of having to hit Control-Shift-Enter, Google realized people were going to screw that up and they made it so you can just delete it. So that's the only difference. So I could reproduce this graph right here. So let's see, I want 60, 66, 72. 6. So again, same thing before, I gotta highlight one more cell. Google is a little smarter in this regard than Microsoft. If you forget to do that extra cell, Google gives it to you anyway. Excel doesn't do that, so you might not know if you missed it. Then I type equals frequency, tab completed, highlight my data. It'll just ignore them. If it was actually the number 0, it wouldn't ignore an empty cell. It would. Then it wants a comma, and it wants to know what the bins are. And then I close the parentheses, I can just say enter. And I can make a graph on it. Now the downside of this graph is I don't have the human readable bins here, and Google won't place them correctly, just like Microsoft. So there's some characteristics they share. Other thing is it wants to graph the bin maxes. So I have to go over here with chart types and say, no, that's a label. And here it puts space in between. So I can get a similar chart, it'll have the same kind of heights. Why might I want the frequency table? Because sometimes instead of frequencies, we do what are called relative frequencies. And a relative frequency is just a percent. 8 people with this pulse rate is what percent of the whole population. So to figure that out, I would have to do a sum on this column. And know there were 67 numbers. So over here, I would go equals, click on frequency, divide by 67, and then pull that down. Percent. So if I wanted a relative frequency histogram, which those are pretty popular too, I would need this. There's also another kind of frequency chart called a cumulative frequency histogram. And I think that would be overwhelming if I showed you that. So I did more than I wanted to do, so we didn't get to the computer lab. So we will play in the lab next class. So let's see. Summarize a few things before the parts. So I fixed this up. We have a new teacher, Danielle, who's now the teacher of the class. She's been promoted to help with fun with statistics and geometry. That happened accidentally. We don't know how Danielle ended up to teach it, but it's kind of cool. I hope that comes with pay too. Yeah. All right. So the first announcement here is a link to directions I posted about how to make a frequency histogram in Excel, and then a summary of the steps that you get. If you try to do that, the M&M data is located in a Google spreadsheet linked here. Link to the recordings is here. Activities for this chapter will be 1, 2, 5, and 7. So we'll just spend all day class on Monday, doing activities 1, 2, 5, and 7. I've covered some of the material in sections 1, 2, and 3.
What chapters are we going through?
10 and 11 for sure, and then we're gonna mix and match with the other chapters. We're just gonna have to.
How many chapters are in?
Instead of a final, you're gonna list five big giant art project.
There'll be a little final and an art project.
How many chapters?
And there's
Not final.
how many?
Chapters, sorry, not book.
Oh, in the book, in the book, I think there's 5 more chapters to do, and we don't have time to do them all.
How many chapters are there?
We'll end up covering probably 3 chapters total. We'll do all of 10, all of 11, and then we'll poke around 12, 13 books. All right, that's it for the 4th. Have fun, do good math and other stuff. Okay. Okay. All right, I will record. Yeah.
And can we, more, like, I'm gonna test out different parts of my house.
Oh, to find the best place for quietness and reception. Okay, sounds good.
So, wait, she's gonna be gone on Monday, and you're gonna be gone?
Oh, it's just gonna be me and you, Greg,
Because I don't
while on campus.
have any other classes.
So we'll have Debbie online for some of it, we'll have Kelly online, and Danielle will be here. That's the downside of a small class.
Sorry.
Extra tension and maybe too much attention. That's okay. How are you doing, Debbie?
You're gonna have to knock out all the activities, and you guys can all do it yourselves.
Oh. All right, you too. Let's see what else. Oh, and then I'm going to find a way to share with you one of my favorite books. So I'll post a link somehow for the cartoon, parts of the cartoon guide to statistics. It's got some really cool stuff. So I have a few failed attempts at trying to get copies of that online. Hopefully this next one will be good. Oh yeah, she's the other teacher, right? She knows all kinds of stuff. All right, I'll see you soon. Thank you.
All right.
Bye-bye.
Bye.